watch it later. Okay.
Okay.
So I'll do that as well. So yeah, I was saying in grade 10, you did the linear function y equals mx plus b. So something like that. That's a function. How do we know? Well, anything is a function, right? If it passes the vertical line test. Now, what's a vertical line test? So if you just take a line, yeah? If you just take a straight line up to down, and if it crosses the graph only once, right? That's a function, okay?
Okay.
So now what would not be a function? So something like this is not a function. So let's say that's our grid, and you have a graph going this way. Now this, if you draw the vertical line, see it's gonna touch it once here. It's gonna touch it once there again. See, it touches it twice there. So this is not a function. But this one is, yeah? Another function that you did in grade 10 was quadratic, y equals x squared, the parent function. That looks like this, looks like a u that goes through the origin. And this one also passes the vertical line test at any given point. So how do you know something is a function? If it passes the vertical line test. Now, what is actually going on here? If you look at this, right, if you were to write this in the coordinate form, let's say that's 2, 4. And let's say this point right here on the graph, that is minus 2, 4. Yeah? You agree with this?
Yep.
So you see here, the y values, it can repeat. Y values can repeat, that's fine. But x values cannot repeat. If x values were to repeat, let's say you had 2, 4, and then let's say you had 2, 5. So 2, 4 would be right there, and then 2, 5 would be right there. It would fail the vertical line test. So that is not a function. X values repeating is fine, but X values repeating is not fine, but Y values can repeat. And a quadratic is an example of a Y value repeating. Okay, let's do some questions from the book. We're just gonna jump right into these. All right. Here, is this a function?
No.
No, right? Because the 15 is repeating. You have 15 with Thursday, 15 with Tuesday. So this is not the function. And another idea in functions is when they talk about domain and range. So domain is the possible x values that the function can take. Now here, these are not equations. Yeah, this is just a relation. This is also not a function, but it still has a domain. Okay. So what's the domain here? It's simply 15, 16, and 17, the possible x values it can take. So every time in like this bubble chart, the left side is the x value, is the domain, and the other side is the range. Okay. So what's the range of this relation?
Saturday, Thursday, and Tuesday.
Yeah, good, perfect. There we go. Very simple idea. Now let's look at this. It says determine which of them are functions. Is A function?
No.
No, right? Because it's gonna fail the vertical line test. What about B?
Yeah.
It is a function. What if we made this a little bit more complicated? What is the domain and range of A?
The domain would be 0 is equal to or less than, or sorry, equal to or more than -4, and equal to or less than 4.
Yeah, exactly. So this is how you write it, yeah? X is the element. This E in the middle stands for element. It's like a curved E, cursive E. X is an element of all real numbers. And even this R, instead of just writing an R, you want to have like 2 R's like that, okay? So X is an element of all real numbers, given that X is between -4, X, and +4. So that's the proper notation. Okay?
Okay.
-4, X, and 4. What's the range?
4 and -4.
Yeah, so the same thing, but range has to do with the Y values. So you say Y is an element of all real numbers, given that it's between -4, Y, and 4. This means Y can be anything between -4 and 4. Yeah? Let's look at B. What's the domain of that function? This is a quadratic, this is a circle. Yeah? So what is the domain of that quadratic function?
I think it would be 0.5 or greater than or equal to 0.5?
It would not be. So for a
No.
quadratic function, the domain is XER. It can be anything. No restrictions on the domain. Same thing with a linear function, any linear function. There is, for a linear function, it's even easier. There is no restriction on the domain, and there's no restriction on the range either. For mx plus b, anything in that form. For a quadratic, for anything in x squared, for a parabola, the domain is XER. No restrictions, but the range, there is a restriction on the range because it'll never be above this point, right? The y value will never be above this value here. But the x, you see these lines, they're going to extend to infinity on both directions. So x can be anything. But the range will never be above this value. So for the range, let's say that is 3.5. This point right there is 1, 3.5. What would be the range of this quadratic function?
Equal to or less than 3.5.
Exactly. So you want to say y is an element of all. Yeah, this is a little bit annoying, but you have to do this every time. And then y is less than or equal to 3.5. And there you go. Okay. So that's pretty basic. We've already talked about the vertical line test. Here, that's from a graph. It's a little bit easier when they give you a graph. But what if they give you a bunch of different equations? How can we tell if something is a function or not? Is A a function?
Yes.
Yes, right. It's a linear function. It's in the form of y equals mx plus b. What about b?
No.
No, b is not a function. What does b represent?
A circle?
Yeah, exactly. What's the radius of the circle? So x squared plus y squared equals r squared. R squared is 9. What is r gonna be?
3.
Yeah, exactly. So this is a circle that goes to 3 on each direction, in every direction from the origin. So 3 minus 3 plus 3 minus 3. So it looks something like this, and both the domain and range is between -3 and +3. It is not a function, but it is a relation. Okay. What about C? Is that a function?
I want to say yes.
It is a function. It's a quadratic in the standard form, and you have done quadratic before. It just means the standard form just means this: ax squared plus bx plus c. So you see the maximum, the highest power for this is x squared. So that means it's a quadratic. Okay, so that is a function. So this part isn't that bad. It's basically like a review of grade 10. All right, what if we complicate this a little bit? Okay, 9, determine which relations are function. Is this a function? Y equals to the square root of x plus 2.
I'm
To
not
understand
sure.
that, you have to understand the parent function. So they're asking whether this is a function, okay? Now, where does this come from? You remember in the previous question, we had something like this. You always kind of want to take it back to its parent function. For this guy, what's the parent function? It's y equals x squared, okay? You see, this is a parabolic function. It's going to be a U-shaped function. The parent function is called the quadratic y equals x squared, okay? For this, what's the parent function? That's a square root function. Y equals to the square root of x. You can graph this. Let's see what that looks like. Yeah, if you're ever confused about things like this, what you can do is you can make a quick sketch and see if it passes the vertical line test, okay? So let's try and graph this. We're trying to graph y equals to the square root of x. When x is 0, what would y be?
0.
0, right? When x is 1, what's y?
1.
When x is 4, what's y?
2.
Yeah, there we go, 9, 3. So we can just make a quick sketch. Again, it doesn't have to be precise. We're just trying to see if the x values are repeating, and they're not repeating, right? So it goes through the origin, then 1, 1, then 4, 2, and then 9, 3. So this is the graph of y equals to the square root of x. Okay, and this passes the vertical line test. This is a function. So now they're asking us whether this is a function. Well, this is just a parent function that's gone through some transformation, some form of transformation, just like this one. This is a quadratic that's gone through some form of transformation. So as long as a parent function is a function, the transformed function will also always be a function. So this is a function. Okay.
Okay.
What if I asked you this? Y equals to 3, 1 over 3. And again, notice, what's the parent function here?
Y equals X.
Not y equals
Square.
x, square root of x. So if I asked you, is this a function? What would you say?
Yes.
Yes. So this is just y equals to the square root of x that's gone through some transformations. It's been stretched and it's moved around a little bit, but the parent function still exists in here. So as long as this is a function, this is also a function. Okay. Let's move on. What about 2 minus x? Is that a function?
Yes.
Yes, that's a linear function. What about c?
No.
No, that is not a function. What about d?
Yes.
Yes, it is. It's a quadratic function. Okay. Let's see. And now in last year's course, you used to write y equals something like this, 3x plus 3. So now in this course, y is going to change. Well, it's still going to represent the exact same thing, but we're going to rewrite y as f of x equals 3x plus 3. Now, why do we do this? Let's make a quick table of values for this one. For this one, if x is 1, what would y be?
6.
Yes. And if x is 0, y is 3. Yeah?
Yep.
So now, how do we visualize these points? I guess we could graph it, but we can't write this as 6 equals 3 times 1 plus 3. We could, but that doesn't tell us anything about what we're doing, or doesn't have any implication with what the function is. So now in the new notation system, what we do is, instead of writing it in this form, we're going to rewrite this in f of 1 is equals to 6. Now, what does this mean? This means when the x value is 1, the y value is 6. You see that? That's the advantage of the function notation. It kind of tells you what's going on. The other one, f of 0, is 3. So what does this mean? This means for this function, when the x value is 0, the y value is 3. Okay?
Okay.
So we'll exclusively be using the function notation. Even next year's course, advanced functions, we're going to be using the function notation. Let's do a quick question, not that one. Let's see. This one looks a little bit annoying. I guess we can do this. The math in this course is not like hard. It's like the word problems. They can be a little bit tricky. So let's see what's going on here. So a family is playing a game to decide who got to eat the last piece of pizza. Each person has to think of a number, right? So let's think of a number. For us, the number is x. Okay. Let's say the number is x. And then we double it. What's going to happen to the x if we double it?
Put a 2 in front.
Yeah, and then we're going to subtract this, subtract the result, which is 2x from 12. So what do we do for this one? So we subtract, this is the result so far. We would subtract that from 12. Okay. Again, we had a number, we doubled it, and this is our result so far, and we're just going to subtract this from 12. Are you good at this?
I think so.
And then finally, they multiply the resulting difference, and notice this is the resulting difference so far by the number they first thought of. So what do we multiply this by?
X.
X, exactly. And there you go. That's the result, okay? And whoever comes up with the final highest number here, they're going to win the last slice of the pizza. It says use function notation to express the final answer. So all we have to do, once we already have the result on the right side, we're just going to rewrite f of x on the left. And that's the answer to part A. Okay?
Okay.
Part B. The original numbers are shown here, and then it says who won the pizza slice. So the person with the largest answer is going to win the pizza slice. So all we're going to do is we're going to find f of these values. So first we're going to find f of 5. So I'm gonna do the first one, okay? It's very simple. So you see before it was f of x equals x times something. All you have to do is replace x with what's in this bracket. So right now I have a 5 in the bracket. I'm gonna replace that x with a 5. So you have 5 there. And then bracket open. 12 times 2 times 5, bracket close. And that gives me 5 times 12 minus 10. So that gives me 5 times 2, and that's going to be a 10. So for Tim, the final answer is 10. Yeah?
Okay.
Let's do it for the next person. So the next one is f of minus 2. So what does the function become?
-2.
Yes. And then in the bracket, what do we have?
12 minus -2, or 12 minus 2 times -2.
Yes. And now you can use a calculator here, or you don't have to. So it becomes minus 2 times 12 plus 4, right? -2 times -2 is a positive 4, yeah?
Yep.
So you get minus 2 times 16, so that is minus 32. So this person's not winning because 10 is bigger than minus 32. Let's look at the next one. Again, we can do the next ones really quickly. So f of 7 is going to be 7 times 12 minus 14. That's going to be -14. And then finally 10 is going to be f of 10 equals 10 times 12 minus 20. And that is going to be -80. So who had the highest? F of 5 had the highest, so Tim won the pizza slice. Okay.
Okay.
Now this one's a tricky question. What would be the best number to choose and why?
Out of the 3 or the 4?
No, like any, out of any. Doesn't necessarily have to be out of these. Out of these, it's 5, but what if you had to go against it? What would be the best number to choose in this game? Now for that, you're gonna have to go back to quadratics, okay? X squared. So x squared has a very special property. The quadratic function in its vertex form looks like this: y equals a, x minus h squared plus k, where h comma k is the vertex. Do you remember this from last year? The vertex
Yep.
form of a quadratic? So basically what we have to do is we have to turn this equation, yeah? Right now it's in the factored form. We're gonna have to turn this into the vertex form to see what value of x gives the highest result. Now there's a bunch of ways to do that. I think the easiest one is this. First, we will find the two x-intercepts. So what are x-intercepts? X-intercepts are when you set y as 0, you just solve for x, or y or f of x in this case, right? So we're gonna set f of x as 0, and then we're gonna solve for x. What do we get as our two x-intercepts? What do you think? What's the next step?
You replace x with 0 in the equation.
No, that would be f of 0. Okay, we're not trying to do that. We're trying to
Oh,
solve for the x, and we're trying to solve this equation for x. What if we have something like this? 3x minus 9 equals 0. How do we solve this equation?
move the 9 to the other
Yeah.
side of the
And
equal.
then divide by 3, right? So that's pretty easy. So when you have something like this, yeah, a quadratic, you're trying to solve it for 0. What you need to do is you need to set the individual brackets equals to 0. So you either have x equals to 0, that's our first x-intercept, or you have 12 minus 2x equals to 0. And once we solve this for x, we'll have our second x-intercept. So I'm just going to add 2x on both sides, and then I'm going to divide by 2. So our second x-intercept is 6. So those are our two x-intercepts, 0 and 6. Okay? Did you get this bit?
Yep.
So again, the goal here is to convert this equation in factored form to the vertex form so we can see what the best number is to pick in this game. So once you have the two x-intercepts, step 2, you need to find the average or find the midpoint of the two x-intercepts. So what's the midpoint of 0 and 6?
3.
Exactly, 0 plus 6 over 2, so 3. And you see 3? That is the best number to pick. We can test that. Before, when x was 5, we got a result of 10, yeah?
Yeah.
So this is our best number to pick. So let's try f of 3. This is gonna be 10. So that's gonna be 3 times 12 minus 2 times 3, yeah?
Yep.
So that's going to be 3 times 12 minus 6. That's 6 times 3, that's 18. And there you go. That's the best number to pick. If you pick 3, you get the value of 18, and that's the vertex. What does that mean graphically? It means this. Is this quadratic opening up or opening down? What do you think?
Opening up.
It's opening down. If you open the bracket, you get 12x. If you FOIL the brackets, right, x times 12 is 12. And then x times minus 2x is minus 2x squared. You see the leading coefficient is negative.
Okay.
And we know when x is 0, y would be 0. So it goes through the origin. Okay, it goes through the origin. And then the maximum value is when x is 3, 1, 2, 3, y is 18. So our graph looks something like this. And our other x-intercept is at 6, so it's going to go up to that vertex point and come back down. So any other x value you pick will not beat 3 because that's where the vertex is. Okay?
Okay.
So pretty simple to find the vertex. If you're given the factored form, just find the two x-intercepts by setting it to 0 and find the midpoint. So the best number to pick for this question is 3 because that gives you a y value of 18. Let's keep going. Alrighty, so now this is just testing the function notation. It's very simple, but you just have to know what they mean. What does g of 3 mean? This means when the x value is 3, what is the y value? That's what this means. Let's look at the graph. When x is 3, what's the y value?
2.
2. So g of 3, therefore, is 2, and that's the answer to A. Okay?
Okay.
Let's do B. What's the answer to B? Now you know how it works.
Positive 1.
No. So what does that mean? That means when x value is negative 1, what's the y value? Right?
Oh, 0.
0. So that's the answer to this. G of negative 1 is 0. Now C. What does this mean? Find x when the y value is 1. You see that? What is
Yeah.
the x value when the y value is 1? G of x just means 1. F of x, anything in a bracket x just means the y. So here, when g of x is 1, when's that 1? Right there. The y value is 1 right there. What's the x value?
0.
Exactly. So the answer to part C is 0. When x equals 0, g of x is 1. Another way of writing that is g of 0 is 1. When x is 0, y is 1. Okay? What about D? The domain and range of g of x.
The domain would be x is equal to or less than negative 1, and it just keeps going from there.
All right, so you go XER, yeah?
Yeah.
Have you seen this? Does your teacher use this?
Yes.
All right, there we go. XER, and then you want to say x is greater than or equal to negative 1. What about the range?
YER, and then y is equal to or greater than 0.
Perfect, there we go. And that's all there is to function notation. Once you can do one of these, you can do all of them. The idea is very simple. Now let's move on to some quadratics. Okay, consider the functions. So we're given two different functions, f of x and g of x. Show that f of 2 is greater than g of 2. So why don't we find both of them? What is f of 2 gonna be? How do we find that?
You put it in the first equation.
Yeah, exactly. So you just replace this x with what's in the bracket, it's gonna be 2. And I keep saying it in that form because you'll see when we're trying to do this, that process of thinking is useful. So 2 squared minus 3 times 2. So that's 4 minus 6, that's minus 2. Yeah?
Yep.
And then g of 2 would be 1 minus 2 times 2. So that's 1 minus 4, and that's negative 3. Therefore, it's bigger than that. So again, f of 2 is minus 2, and g of 2 is -3. So we know this is bigger than this because -2 is bigger than -3. How does that work, by the way? It works like this. Let's say this is the number line. There's a 0 there, yeah? The number on the right is always bigger than the number on the left. So -2 would be here, -3 would be here, yeah? Since -2 is on the right, this number is bigger. Okay?
Okay.
But for the second part of part A, and explain what that means about their graphs. So what does this mean about their graph? The fact that f of 2 is greater than g of 2. So we know both of these represent functions, right?
Yeah.
So here, it just means the y value for this one is greater than this when x is 2. So x is 2, this has a negative slope with a y-intercept of 1. I can just make a quick sketch. And when y is 0, you have 0.5. So this is the graph for g of x. I'm going to try and make a quick sketch for this. This is a parabola that opens upwards through the origin. Looks something like this. So the red one is f of x, okay?
Okay.
Now let's look at what happens when the x value is 2. When the x value is 2, the y value of f of x, you see, it's a little bit higher than the y value of g of x. So that's what this means. When the x value is 2, the y value for the f function is greater than the y value for the g function. Okay?
Okay.
It's not that bad, yeah?
Yeah.
Let's do part B. Determine g of 3b. Let me overcomplicate this for a second so you can do questions like these. So we know g of 1 would be 1 minus 2 times 1. Yeah?
Yeah.
Now let's do something a little bit goofy. Let's say g of 3. What would that be equals to? It's going to be equals to, yeah, you tell me.
3 minus 2 3.
No. 1 minus 2 times 3. Right? We replace x with what's in the bracket. Yeah?
Okay.
Let's keep doing one more of these and you should be able to do any of these types of problems. Let's say g of like something very like stupid, like I don't know, sine x plus cos x. This is actually not stupid. This you will see as a question. I'm going to do this for you, okay? Again, it's very simple, the idea. You see the x is only here for g of x. What we're going to do is we're going to replace this x with what's in the bracket. So this becomes what?
1 minus 2 times sin x plus cos x.
Yeah, there we go. And by the way, these are both functions that we will be doing later on. This is from the trig unit, trigonometry. It's pretty fun. Here, I'll show you what they look like. It could be a little bit daunting though. Sin x looks like this. It's fun because it keeps repeating. You know, every other function we do, like it never repeats. But both of these are like periodic functions. They keep looping around and they're fun to play around with. Right now, once we establish how to do this, we can answer what's g of 3b gonna be. So part B, g of 3b, what would that be?
1 minus 2 times 3b.
Exactly. And if you just open this, it becomes 1 minus what? If you open this bracket?
6b.
Yeah, 1 minus 6b. Now, what does this mean? Like hypothetically, what does this mean? This means that when the x value, yeah, for the function g of x, when the x value is 3b, the y value is 1 minus 6b. Okay?
Okay.
Let's do part C as well, why not? So it says determine fc plus 2 minus gc plus 2. We can do this in one, well, in the same thing. So what would fc plus 2 be? F of x is this function here.
Like the equation part?
Yeah, so what's the next step here? Determine fc plus 2 minus gc plus 2. If f of x is this, what's fc plus 2?
X squared times, or sorry, no, there'd be 2 brackets of c plus 2.
So again, f of x is this, right? So f of c plus 2 would be, again, notice, replace this x with what's in the bracket. C plus 2 squared, yeah? Minus what?
3 times c
C
plus
plus
2.
2 in a bracket. There we go, right? Minus, now what's g of c plus 2? It's gonna be 1 minus 2, yeah? Times c plus 2, like that. Okay?
Okay.
And whenever you're subtracting something, it's good practice to put a bracket around this. Whenever you're subtracting something, just put a bracket around that term. And now let's open this up. We can do this on the sides. What's c plus 2 times c plus 2?
C squared plus 2c.
Yeah.
Plus 2c plus 4.
Yeah, exactly. So these are like terms, so we can just add them up. So this becomes c squared plus 4c plus 4. And why don't you open this bracket? The one with the 3.
Negative 3c minus 6.
Yeah, good. And let's open this bracket as well. Actually, we can just keep that in there. So this becomes minus, and again, the bracket is right there, 1 minus 2c minus 4, like that. Yeah?
Yep.
And we always need to put a negative sign. When we're subtracting something, we always need to put like the bracket around it. Now let's open this bracket. You get minus 1 plus 2c minus 4. Good so far?
Yep.
Now let's look at the like terms, and then we'll just finish this question. So there's only one c squared, so that's going to be by itself. And then c's, we have 4c minus 3c, which is 1c, and then we have 2c here. So that entire thing adds up to 3c, right?
Yep.
4 minus 3, 1c plus 2c, 3c, and then finally the numbers, we have plus 4 minus 6, which is minus 2, minus 2 minus 1 is minus 3, minus 3 minus 4 is minus 7, and there you go. That's the final answer for this question. Okay?
Okay.
What if I asked you, what does this mean? In the context of this question, what does that mean?
It's f, right? Yeah, f minus g, like the f of x minus g of x.
So what if this was a communication problem, right? If you know, you're graded on 4 different elements in any course: knowledge / understanding, application, thinking, and communication. So a question like this can come up as a communication question. It's like part D, explain the answer to part C. What does that represent in the context of this problem? So this is what it means, right? It might sound a little bit complicated, but it's really not. So in part A, right, we established that our quadratic looks something like this. And then at 2, the main function at 2, the quadratic was higher than the linear function, yeah?
Yeah.
So this was the answer to part A. Now for this question, part C, what this means is that for any arbitrary point, for any arbitrary x value of c plus 2, for any arbitrary value, x value of c plus 2, the difference in the y values is this. Because this is a difference in the y value, right? F of something minus g of something. That's the difference in the y value. So the distance from this point to this point for an arbitrary x value of c plus 2 is this. That's what it means. Okay?
Okay.
Yeah, that one was a little bit fun. I guess that depends on your definition of fun. I'm gonna kind of run through this a little bit. Oh, let's explore some parent functions. Yeah, so how many have they given here? 5. So let's look at 5 of them. And we're just gonna briefly talk about its domain and its range. So the first function is this linear function, y equals x. This is the parent function. The domain and range for both of these is XCR and YER. It has no restrictions. It's going to go to infinite, both on the left and down and up and right. The next function is the quadratic, y equals x squared. Remember, what's the domain and range for this?
The domain is infinite
Yes.
and the range would be equal to or greater than 0.
Yeah, perfect. So these are the ones that we've been doing so far, right? But now they've added some extra ones here. Square root 1 over x and the absolute value function. Let's look at this one first, the absolute value function. You see these two lines on the sides of x?
Yeah.
This means it's the absolute value function. Now, what does it do? Absolute value function. So all it does is it gives you a positive number as a result. It's very simple. The absolute value of 2 is just 2, nothing changes. The absolute value of 5 is just 5. But if you were to put a negative number in there, it's going to give you a positive number like that. The absolute value of negative 2 is positive 2. The absolute value of negative 10 is positive 10. Okay?
Okay.
Graphically, it looks like this. It looks like a V at the origin. And in terms of properties, it is extremely similar to the quadratic function. This one is like a curved around the origin, right? But this one's like a very sharp turn. So what could be the domain and range of the absolute value function?
The domain would be infinite and the range would be equal to or greater than 0.
Perfect. There we go. Now the next function is the square root function. Y equals to the square root of x. And you cannot have a negative number in a square root, right? So that is why this function starts when x is 0. And when x is 0, y is 0. Because if you have the square root of -1, that's an error. Because there's no number, when you square it, you get -1. So the square root function looks like this. Like that, okay?
Okay.
What's the domain and range of this? You can just decipher that through the graph.
The range would be greater than or equal to 0 and the
Yeah.
domain would be greater than or equal to 0.
Yes, exactly. Pretty simple, yeah?
Yeah.
And then after we're done with all the functions, we're going to do transformations. You know that, right? That's probably the more complicated part of this chapter 1. And then finally, you have the reciprocal function, which looks like this. Y equals 1 over x. And again, if x were to be 0 here, you would get 1 over 0 and you cannot divide by a 0, yeah?
Yeah.
So 1 over x, this is called the reciprocal function, and it looks like this. So what's the restriction on this? What's the domain and range? So unlike the other functions where they were greater than or less than something, here the restriction is that x cannot strictly be 0, and that's the only restriction. X
Okay.
can be anything apart from 0. Same thing with the range. Y can be anything. Y is an element of all real numbers, except y cannot be 0. Okay?
Okay.
And that is the reciprocal function. That one's pretty easy. All right. Now this one could be a little bit more complicated. Let's talk about transformations, because that's what you'd use to decipher what the domain and range is like quickly. Any function, doesn't matter what it is. We just listed out 5 of them. There's sine, cosine, there's like an infinite number of them. Any function has this form. F of x is equals to, again, f of x is, you don't have to write it, a times f is the function, whatever the function could be, bracket open k, another bracket x minus d plus c. Any function will always be in this form. For example, let's say we had the quadratic. So it'd be 3 times function here is the quadratic function, which is x squared, and then x is in there. So you have 4x minus 5 squared. This is the quadratic plus 6. Another example could be the square root function 3, and f here would be the square root function 4x minus 5 plus 6. You can also have the absolute value function like that, plus 6. Okay, you see how this works?
Yep.
Any function will be in this form. And from that form, you have to decipher what the a, k, d, and c is. And that'll tell you what the transformations are. So let's look at a. What's the a in all of these functions?
3.
3, right? A is 3. Now, if a were to be negative, then in terms of transformations, that's a reflection on the x-axis. Like a quick example, y equals x squared goes to y equals minus 2x squared. What is the a value?
-2.
Exactly. So y equals x squared looks like this. So y equals negative. See, y is negative. It's going to flip upside down. So that's called a reflection in the x-axis. Okay?
Okay.
If a is negative, that's a reflection on the x-axis. And if the absolute value of a, you know what that means, right? If it's a negative number, just make it positive. If the absolute value of a is greater than 1, it's a vertical stretch. If the absolute value of a is less than 1, it's a vertical compression. All right, quick pop quiz. Y equals minus 3x squared. What are the transformations here? What are the transformations that brings us from y equals x squared to this?
A reflection across the x-axis.
Yeah.
And a vertical compression.
No, the absolute value of a.
Oh, vertical stretch.
It's a vertical stretch by a factor of 3. Okay.
Okay.
And then we keep going. The next one is the k. K is 4 here, yeah? If k is negative, instead of it being a reflection, it's still a reflection, but it's a reflection on the y-axis. Now, how does that work? Here, let's look at this. Y equals to the absolute value function, like that, right? Y equals to the absolute value of negative x. What is the k value? K value is the number that's multiplied to the x. What's multiplied to the x here? -1, right?
Yeah.
But what we're concerned with is whether k is negative or not. Yes, it is negative. This is actually not a very good example because absolute value function is a symmetrical function. So even if you were to reflect it on the y-axis, nothing would change. You'd literally get what you started before. A better example would be the square root function. All right, this is a square root function with the k value of -1. So we know that's a reflection across the y-axis, right? So what does that look like? Again, the parent function looks like this, starts at 0, 0, and goes in this direction. This is the y-axis. That means when k is negative, instead of it going right, it goes left, like that. Okay?
Okay.
Another example is the linear function, y equals to -x. Actually, for a linear function, a and k is the same thing, so it actually doesn't really matter. Did you understand this? K is negative?
Yep.
Now let's look at this one. Now this one's gonna be a little bit confusing. K is also the stretch factor, stretch or compression, but it's the horizontal one. But the way it works is the opposite way. Here, what do I mean by that? If the absolute value of k is bigger than 1, you would expect it to be a stretch, but instead of being a stretch, it's a horizontal compression. For example, let's say we have y equals to -3 of x in a square root. So the transformations here, again, the minus sign means it's a reflection on the y-axis, yeah? What does the 3 do? That's the k value, and that's bigger than 1. The absolute value of it is bigger than 1. What does the 3 do?
How It's like far compresses.
So the technical definition is this. It's a horizontal compression by a factor of 1/3. Okay.
Okay.
And if the absolute value of K is less than 1, then it's a horizontal stretch. For example, y equals to 1/3x, or let's say 1/4x. What does the 1/4 do to this function? Is it a horizontal compression or is it a horizontal stretch? It's not negative, so we're not concerned with the reflections.
Stretch.
Exactly, it's a horizontal stretch by a factor of 4. Okay.
Okay.
Now here, what's D? D and C are super simple. What's D here? +5 or -5?
Or +5.
+5, exactly. If D is positive, it goes right. If D is negative, it goes left. Same thing with the C. C here is 6. If it's positive, it goes up. If it's negative, it goes down. Okay.
Okay.
So vertical stretch, compression, horizontal stretch, compression, reflections, and then these are called shifts. D is called a horizontal shift, either goes right or left, and C is called a vertical shift, either goes up or down. Cool?
Okay.
Alrighty. With that in mind, let's try and find the domain and range of these functions. And that's basically the crux of this unit, the transformations. If you kind of understood that, like we'll do a bunch of these problems, you should be comfortable. You should feel comfortable with it. So here, it's asking us for the domain and range of a linear function. What could it be?
I'm not sure.
For a linear function, doesn't matter, XER, YER. Doesn't matter what they give you, like even if it's going this way, doesn't matter. It's always gonna be XER and YER, okay?
Okay.
Let's look at B. Now what's going on in B? What kind of function is that?
Quadratic.
Quadratic function, right? I mean, there's two ways to graph this. You need to kind of see it where the vertex is to state the domain and the range. Well, the domain for a quadratic is the same as linear, always XER. The domain for the absolute value function, for quadratic, for linear is always XER. Now, where's the vertex for this? And we can use our transformations to do this, right? Compare this with this. So we know the domain is XER because it's a quadratic, it's gonna go infinitely to the left and the right. But on the Y, it has a strict limit. So compare this with this, A x minus D squared plus C. What is A?
-3.
What is D?
-1.
Yes, good. What's C?
6.
6, right? So what does this mean? This means from the parent function, let's say it looks like this. Our graph has reflected on the which axis? X-axis or the Y-axis?
X.
Exactly. It's flipped upside down. So now it looks like this. Okay, now we've dealt with the negative sign. What does a 3 do?
It's
Vertical stretch, horizontal stretch, compression, horizontal compression. One out
vertical
of
stretch of 3.
exactly. Vertical stretch by a factor of 3. So what does that mean? That means it just elongates vertically 3 times as long. It just like kind of stretches. Okay, like that. It becomes long, right? If you, let's say if you have this amount of thread, if you were to stretch it, it's gonna shrink a little bit, yeah?
Yeah.
So we've done the 3 as well. What does the -1 do?
It goes left.
Good.
1.
And what does the +6 do? C6.
It goes up 6.
Exactly. So you see our vertex, so it went -1 here. And then finally, again, there's too many graphs here. I'm just gonna draw you the final one. The final one looks something like this. So its vertex would be at -1 and +6 and goes downwards like that. So what is the domain and range of this quadratic function?
The range would be XER.
The domain is XER, no restrictions on the domain. The range will be YER, okay, in terms of Y, but it has a restriction though. What's the restriction for the range?
It's equal to or less than 6.
Exactly. So y is less than or equals to +6, and you're done. You see these three? This 3 has no effect on the domain and range. The only thing that affects the domain and range is either reflections, if it's reflected up, down, or left, right, or like shifts, if it's moved up, down, left, or right. The stretches and the compressions have no effect on the domain and the range. It is going to affect the graphs, but not the domain and the range. Okay?
Okay.
There's another way you could have constructed this graph without using transformations, and that's by comparing this with this x minus h squared plus k. You see the vertex hk is at -1 and +6. And we know this graph is opening downwards because the leading coefficient is negative. That's also a way you could have constructed this graph. Cool.
Okay.
Let's look at C. So what's the parent function there?
The x square rooted.
Yes, exactly, square root of x, right? So now this one's a little bit tricky. It's not in the right form. What we need to do is we need to take this into the right form, because you see x is being multiplied by -1, yeah? But we need to have whatever the k value is, like we need to pull it out of the bracket. It always needs to be in this form, okay? So what I'm gonna do here, h of x, I'm gonna pull out a -1 in the bracket. If I pull out a -1, what am I left with?
2 plus x.
Oh yeah, -2 plus x, or x minus 2. Right, if you take out a -1 from +2, you get a -2. Yeah?
Okay.
You can always open this bracket again to go back where you started. -1 times x is -x, and -1 times -2 is +2, like that. Now compare this with this. What's a? It's a trick question.
1,
1, right? So we don't care about a being 1. What's k?
2.
No, k is not 2.
Oh, -1.
Exactly, k is -1. What is d?
2.
What is c?
0.
Good. A and k will never be 0. If it doesn't exist, it's a 1. And d and c, if it doesn't exist, it's going to be a 0. So we're not concerned with c being 0. So these are the only two transformations, yeah? So let's do them. So our parent function looks like this. So what's happened to it? K -1. What does that do in terms of transformations?
Is it?
It's a reflection.
Yeah.
On which axis?
The
X-axis?
y-axis.
Correct. So instead of flipping upside down, this would be minus square root of x. That's when a is negative, but that's not what this question is. So this is a reflection on the y-axis. So instead of going right, it's going to go left like that. And what does the 2 do? D being 2. Left, right, up, or down?
Right 2.
Exactly. It's going to go now. It's going to go right 2. And our final graph is going to look like this. Our starting point is going to be on the 2 on the x, and it's going to go leftwards. Okay? That is the graph for this guy, the green one. And let me just redraw it. So from 2, it's going to go this way. Now look at this graph. What is the domain? Now both of them have restrictions.
The domain is equal to or less than 2.
Yeah, good. So XER, semicolon, x is less than or equal to 2. What about the range?
It's greater than or equal to 0.
Good, perfect. And there we go. Okay. Yeah, once you understand transformations, like domain and range and everything is going to be pretty straightforward. Let's try another one. We're going to find the domain and range of this function. How do we start? We're trying to find the domain and range of this.
I'm not sure.
So we just have to, again, we just have to take anything they give us into this form. Well, here f is, what's a parent function?
The square root of x.
Yeah, exactly. We need to take this into this function. So ask yourself, what is being multiplied with the x? -1, right?
Yeah.
If it was like this, then we don't need to do this. Because 1 is being multiplied with the x, k value is 1, nothing changes. But here, x is being multiplied by -1. So that's significant, okay? So here a doesn't exist, we don't care about that. We're gonna pull out a -1 from this. What are we left with in the bracket?
X minus 3.
Perfect. Now compare this with this. A is 1, we don't care about that. What's k?
3. Or
K is not 3.
no, -1.
Yeah, what's d?
3.
What's c?
2.
So if this was the parent function, what happens to it? What's the first thing that happens to it?
A vertical stretch.
There's
Or
no vertical
no,
stretch here.
a reflection of the y-axis.
Yeah, so it's called reflection on the on the y-axis or over the y-axis, okay? The blue one is right there. We're done with this. What does d being 3 do?
Right 3.
Exactly. Right now it's at the origin 0, 0. Now it's gonna go to 3, 0. And it's still gonna go this way, right? What does c do?
Up 2.
Exactly. So our final point, therefore our final graph looks like this. At 3, 2, that's where our function starts, yeah? And it's gonna go this way. You see this?
Yep.
And that's how you find the domain and range. So what's the domain of this function?
X is equal to or greater than or equal to or less than 3.
Yeah, perfect. What about the range?
Y is equal to or greater than +2.
Yes, perfect. And there we go. All right. And once you can do this for one function, like it's literally the same for any other function. For example, instead of it being like this, right? Let's say it was the absolute value of 3 minus x plus 2. Again, x is being multiplied by -1. So you're going to pull out the -1. And then we're left with x minus 3 in the bracket plus 2. Yeah?
Yep.
So our absolute value function looks like this. Step 1, it's a reflection on the y-axis. Now, absolute value function and quadratic, they're symmetrical functions about the y-axis. So even if you flip it here, literally nothing changes. So this does nothing to it, right? If you put a mirror here, you get the exact same thing that you started off with. So that does nothing. What does x minus 3 do?
It goes left or right.
Goes
3.
right, goes right and goes up, right? So our same thing, our boundary value now is going to be 3, 2. What is the domain of this absolute value function?
X is x. No, it's just XER.
Yeah, good. What about y?
Y is equal to or greater than +2.
Yes, YER, colon, y is greater than or equal to +2, and you're done. You see that? Once you decipher what the AKDC is, it doesn't matter what function they throw at you. The procedure is literally the same. Okay?
Okay.
Wasn't that bad, right?
No.
Yeah, it's not that bad. It's pretty fun. And chapter 2 is, I think, even easier than chapter 1. So we'll pick it up next time.
Okay.
All right, I hope you had a good session.
Thank you.